Okay, 12. Welcome to my GRE math subject section, so number 63. Ask you about y equals x12 to y equals x t 2x, and how many points they intersect. So basically, what is asking about the roots. Suppose f is equal to x to 12 minus 2 to x. Ask about how many real roots. Difficult, right? It looks difficult to see. So basically, all we can use is the intermediate theorem, right? So basically, let me build a table. Probably it's not good. So basically, this is x. Let me see. So this is x. Okay, this is x. So x to negative infinity to minus 1, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or keep going. Okay. And the second, we want to compute x to 12 and 2 to x. Okay. So this is infinity, right? And then this is 2 to 12, 1 to 12, and 0 and 1 to 12, 2 to 12, 3 to 12, 4 to 12. So you all you know is this 12 power is very, very large. Okay. And the 2, so when x equals to negative infinity, this is 0. It's 1 over 4, right? A half and a 1. And this is 2, 4, 8, 16, 32, 64. Okay. Okay, so we compute x12 minus 2 to x. Infinity, this is 2 to 12 minus 1 over 4, 1 minus half minus 1. This is 1 minus 2, and 2 to 12 minus 4, 3 to 12 minus 8. Keep going. Okay. So each time you see the sign flip, there must be a root, right? And when you know that you compute minus 3, this is 3 to 12, so it's 1 over 8. So this is 3 to 12 minus 1 over 8. So this one is larger than 0. So larger than 0, larger than 0. This is 0.5, right? This one is less than 0. So you see, there must be a root. There must be a root here, right? And then this is this is minus 1. Oh, this is minus 1. Right. So for 1, yeah, it's 1 minus 2 to, yeah, so it's minus 1. And then when x equals 0, then it's minus 1. Okay. And then when, so this is larger than 0. This is larger than 0. Okay, so you know there is a root from here to here. So from 1 to 2, there's a root. And then there is a root. Okay, but there is a final root that you already know, because 2 to x is larger than x to the 12 when x is really large. Right, I think everyone knows about this, because 2 to x is the exponential function, which is larger than the polynomial function when x is very large. So when x is very, very large, you can find some until some point x naught. Now 2 to x naught and x naught to a 12. This one is larger than this one, so this must be positive. This must be negative, right? Because we use s12 minus 2, so this must be negative. So there must be some roots from here to here. So there is a root. Okay, so totally how many roots we have? 1, 2, 3. So totally we have 3 roots. So the correct answer is D, 63. Answer is D, 3 roots. 3 roots. Yeah, so that's it. Be careful.